All right, let's move on. Let's move on. So we're going to start talking about exponents. Still with me? Yeah. Yeah, I'm done with conspiracies for now. So let's talk about exponents. Exponents are a way to kind of group things together and make it small. So rather than having a whole string of things being multiplied together, if I was multiplying that together, this would be the same thing as 3 raised to the 1, 2, 3, 4, 3 to the 6th power. That means I'm taking 3, multiplying it times itself 6 times. So 3 times, When you start dealing with exponents, you can get to numbers that are way too big. You can get to numbers that your calculator is not going to handle, or the calculator will put in scientific notation because it can't handle that many iterations. Okay? Exponents are pretty easy to deal with as long as you know the properties of them. So I'm going to hit 2 properties on exponents that are pretty easy. The first one I'm going to make here. Okay, so a few things that exist here is you have the base, and then you have the exponent. Or you have the base, and you have an exponent to an exponent. Okay? So exponents, when they're sitting right next to each other, you just count. The properties you just count. So exponents, when they're sitting next to each other like this, you just count. If the bases are the same, you just count. This becomes x to the m plus n. When exponents are raised to each other or are on top of each other, they get multiplied. Okay? So I'm going to use the first rule and go over a couple examples so you can just see the pattern that takes place. But that's basically, so you have one that's multiplying 2 bases together, which both have exponents. Those 2 bases happen to be the same. We're going to add the exponents. If I have exponents on top of each other, they're going to multiply. Okay? Can I clear this for now? All right, so I'm going to use this property. All right, so Angelo, you're my first person I'm calling on. If I have 3 to the 7th power times 3 to the 8th power, have the answer as an exponent, what do you think the answer should be? 3 to the what power? 15. Perfect. How'd you get there? Added the exponents. So like bases, a 3 and a 3 are like exponents, right? Either both have an or both bases, like bases, we have an exponent in the same place. I'm going to add them together. Okay, Mr. Summers, 2 to the 15th, 2 to the 18th. What do you think? What's my base, first of all? 2. 2 is the base. Everyone get that? Yes. And then what am I going to do with 15 and 18, do you think? Add them together. So 15 plus 18 is, I believe, 33. Yes. Is that right? Yes. Yes. Now, if you were to use a calculator, 2 to the 33rd power might be too big of a number. Heck, 3 to the 15 might be too big of a number. Okay, I got to sneeze. It's going to come here in a second. Pineapple didn't work.
It tried to.
I did. All right, now, let's say I had 7 to the 5th and 8 to the 6th power. Do I have like bases there? No. No, 7 and 8 are not the same. Okay, so I cannot combine the exponents together. So basically, you either have to figure out what this problem is. So it's 7 to the 5th, so 7 times 7 times 7 times 7 times 7. And then 8 to the 6th, 8 times 8 times 8 times 8 times 8 times 8 times 8. And then you get some big old number. Or you could just leave it like that. That's as simple as it comes. So these are not like bases. So the rule, I cannot add the exponents together. Does that seem kind of simple? So the bases have to be the same. And if I'm multiplying them, then I will add the exponents together. So it's kind of like you're counting the exponents. Okay? Counting the exponents. So think about this like the bunny population. If you walk over there to some grassy field on campus, and you see bunnies, and they're next to each other, you're just like, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You just count them. Does that make sense? So we could say exponents are like bunnies when they're next to each other. You add them, you're just counting them. What's that? There you go. So you got the bunnies and the crows all next to each other. You have to count them, saying, okay, I have 15 bunnies, 7 crows. All right, can I clear this? Now let's do this. So if exponents are on top of each other, they multiply. So if I had 3 to the 5th to the 6th, anyone want to take a shot at what that would be? Go ahead.
3 to the 5th times 6.
What's 5 times 6?
30.
30. So 3 to the 30th power. Okay. So power to power, exponents on top of each other, they multiply. Huh. All right. Kruger. What do you think? To the? Yeah. 7 to the 8th. So power to power, 7 to the 8th. So if exponents are on top of each other, they multiply. What? Yeah.
How do bunnies get their name? Like, isn't the right terminology rabbits, but where does bunny come from?
I don't know.
I think bunny is the children.
Maybe it's because of their tail.
I don't know.
That's actually
Like, it's true. The little tail is a little hot. Bunny.
Where did they ever think of the name platypus?
Oh, we just went all wrong. All right. We just went all wrong.
This was here, and then we took a U-turn.
No, I don't want to black. I don't know.
Do you guys know that butterfly is called butterfly because it came with Yeah, it was originally flutterby, but the king called it butterfly and no one dared to correct him. It became a thing.
All right, let's work through these. Let's see how we do.
Wouldn't that be 10?
Let's see if we can work through these. So, very first one, 5 to the 2nd to the 3rd, exponents on top of each other. So we do what? Go ahead. 5 to the 6th power. I like it. 5 to the 6th power. Okay? Christian. What's the second one going to help us out to? 15. So they're next to each other, so we add them. So if they're on top of each other, they multiply. If they're next to each other, you add them. Now, that last one. What do you think?
Okay, so you do 3. Wait, so you do 5 times 2. That's 10. So it's 3 over 3 to the 10th power, and then it would be 3 to the And
Okay.
then it'd be 10 plus 7, so it'd be 3 to 17.
Woo!
Bravo!
No applause, just throw money. Huh? What do y'all think? Does this seem okay? So exponents are like bunnies. If they're next to each other, we count them. Made the connection yet? So exponents on top of each other, they multiply. Exponents next to each other, they add, they count. Oh. I don't know if that's on today's worksheet, so I don't want to get there yet. But if they are on top, or if they are divided, it's a tug of war. And we'll get to that later.
Are we gonna have a test on this? Or-
Right this second? No.
Wait,
But-
on exponents.
Yeah, soon. All right. Last thing I want to cover real quick. Last thing I want to cover is this. Let's say I had -3 squared. What is 3 squared? 9? 3 times 3 is 9, right?
Yeah.
But here's a problem. Is it -3 times -3, or is the 3 squared? So this is actually written like this. Because I have the 3 squared. What is that answer? -9. Okay? Now, if I did this, how many -3s are being multiplied together? 2. So that's -3 times -3, which is +9. But this one yields me an answer of -9 because I am squaring. This is my base. That's what's being squared. The negative's coming along for the ride. The negative property is a lower mathematical operation than an exponent. So it has to be taken into account after the exponent. But if I were to group this, this means -3 times -3. Negative times negative is positive. Remember, 2 wrongs make a right. It gives you a +9. All right. I think I want to do this. And I think we can do this pretty well. Okay, so it's worksheet number 13. And I want you to do 1 through 30. Now I'm going to tell you that 7 through 10, I think you can think through it in order to solve it. I think you can just think through them and solve it. Now, in my opinion, if we get all 30 of these done in the next 17 minutes, that means that you're going home with nothing to work on.